Finding critical numbers. So here's a quick description of what they are. Critical numbers of a function are those values of x. So a critical number are values of x in the domain, right? So you can't pick guys that are not usable, that have the property that either the derivative is 0 at that value of x, or the derivative is undefined. And we spent yesterday doing a whole load of fractions. And now we're going to move over and on to radicals. And we're going to see how you just find critical numbers of those. And once we get all these critical numbers done, we then move on to the last part of this section, which is how do you find the absolute max and minimum of a value of a function in a given interval. Right, if you want to differentiate a square root, a cube root, the first thing you're going to have to do is write it as a fractional power. So a cube root is 1/3 power. What you then can do is differentiate, and the chances are that you're going to do a chain rule. So it's going to be 1/3 16 take away x squared and reduce the power by 1, which gets you -2/3, and then the inside function. So you finish by differentiating the inside function, gives us a -2x, and then your style points. So let's see what we get. I'm going to have -2x on the top. That 3 can come downstairs and that can become positive. And then a little bit more and we're finished. So it's -2x over 3 lots of the cube root of 16 take away x squared squared. Are we good? Any questions so far? Now, let's find the critical numbers. Well, the derivative is going to be equal to 0 when the top and only the top is 0, and that gives me an x equals 0. And then I'll go back to the original function and say, can you actually plug 0 in here and get an answer? And the answer is yes. So check. That is a critical number that I can use. Now, the other type of situation is when it is undefined. And undefined happens when the bottom is 0. And as messy as that looks, this is not going to be 0 unless the guy inside the cube root is 0. And I can do that in my head and hope you can as well. You get two numbers, plus and -4. Now, if the original function had been a fraction, I would have thrown these two out because they're not in the domain. But the original function was not a fraction, it was a cube root. And you can plug 4 in here and get an answer. You can plug in -4 and get an answer. So these do count as critical numbers. So in your list, you know, the box in WebAssign, it would look like that, -4, 0, 4. Now you notice the difference between yesterday and today is that these undefined values, in this case plus and -4, are usable in the original function. You don't check, is it usable in the derivative? Because by their very nature, they're not going to be. You only check, is something usable in the original function? So there we go. Any questions about that one? Are we good then? Okay. In this question, we're going to do a product rule. So f dash j plus f of g dashed. If you differentiate this guy, you get 4/5 x to the negative 1/5, and then you leave that one alone, plus you leave the first one alone, and you differentiate x minus 2 squared. And if you differentiate x minus 2 squared, you get 2 lots of x minus 6 to the 1, technically times 1. Guess I shouldn't have bothered writing down times 1 because it doesn't do anything. Now, style points are crucial to being able to find the critical numbers. If I just left these two guys alone and I said to you, can you tell me when the derivative is going to be 0 or undefined for that matter, would you agree you're going to have a hard time? You can't. Unfortunately, this is one of the most difficult versions of style point because we're going to be doing common factors. And in particular, what makes it tricky is the common factor that's the power of x. So let me do the easy common factor. Both of them contain at least an x minus 6. There is an x to the power of negative 1/5, and in this guy, there's an x to the power of 4/5. What is the common factor that we use? What power of x goes here? 4/5 or negative 1/5?
Negative 1/5.
Right. We've seen this not many times, but we've seen this a few times, right? Okay, let's see what we got then. 4/5 still there. Next, x to negative 1/5 used up. X minus 6, only one of them used up. So that's the first term. Plus, there's a 2 here. That's used up. There's a 4/5. And this is the sneakiest part of the whole process. 4/5 take away negative 1/5. What do you get if you take a 4/5 power and you subtract negative 1/5 from it?
1.
You add it?
You add it and you get x to the 1. So let's make it look a little bit prettier. We have an x minus 6 here. This guy can go downstairs. If I multiply that out, I get 4/5 x, take away 24/5 plus 2x. And the 1/5 becomes that guy. Okay, that guy and that guy get you 14/5 x, take out 24/5. Their style points has done its job. Right, it's factored the heck out of it, and it looks like the original. Actually, looks a little bit better than the original. So let's go for the critical numbers now. The derivative is going to be 0 only when the top is 0. Well, the top is that. And that is going to be 0 when x is 6. Let's check it. Can I use 6? Yes, I can. So that's good. That's messy, but I should be able to eventually solve that. Can you trust me that the answer ends up being 24/14, which in turn becomes 12/7? You trust me on that? That's what you get. Now, can I use 12/7? Yes. Yes, I can. So check. And the other type of critical number is when the derivative is undefined. And in this case, it's when the bottom, and only the bottom, is 0. And that's almost trivial. Would you agree that x equals 0 is how that ends up being 0? And then I go up here and I check it. Nothing to the 4/5, negative 6 squared. I can use it. And so we have 3 answers to the critical numbers. We have smallest first 0, 12/7 and 6. Okay, that one was a product rule with a really ugly common factor, right? Messy algebra. Any issues with that one before we move on to the next one to practice with? Okay. Trig. Now, in question 11, they ask us to find, like all the others, all the critical numbers. And then it says, enter your answer as a common separated list. That's normal. And then it says, use n to denote any arbitrary integer value. Okay. If you differentiate this function, you get 1 minus the square root of 2 cosine of theta. So this is an example of dealing with a trig function. Now, critical numbers. When is the derivative equal to 0 becomes solving when is this guy equal to 0. And the world's full of coincidences. My pre-calc 2, my trig class are doing that right now, solving the equations. Okay, as long as you do it to both sides, it's okay, Rob. Does someone want to tell me some of the things I should be doing to both sides here? And the order you do is important.
Minus 1.
Say again, Cara.
-1.
Agreed. So you subtract 1 from both sides. What should I do now to find the cosine of theta?
Divide by negative square root 2.
Now, since both of these are negative, that means that the answer is positive 1 over square root of 2. Agreed? Now, if I make that pretty, style points, by multiplying it by this, you get a guy that I think you should recognize. Do you recognize the cosine is root 2 over 2? Because we're going to be using our unit circle. Is the cosine of an angle the x coordinate on the unit circle, or is it the y coordinate?
X.
Correct. Now, if you look at my unit circle, do you see there's an x coordinate of positive root 2 over there, and the angle, because we only do radians in calculus really, is that one. Is there anywhere else in the unit circle that has an x coordinate of root 2 upon 2? Because that also is one of these solutions.
7 pi over 4.
Let's point at it. You agree? This one here. So you kind of need that. I know you don't need every question or most questions, but don't you need to have a unit circle handy when trig's involved? Because you're never quite sure when you're going to use it. Now, if the question had been find the answer in the range 0 to 2 pi, that would have been the only two answers I've got. But this question had this funny thing about an integer n. And the reason why they talked about this integer n is that, technically speaking, let's look at this one. That's pi upon 4. Couldn't I also go round the circle again and finish up at pi upon 4? So wouldn't that guy plus 2 pi, wouldn't that also work? And wouldn't that guy plus 4 pi and 6 pi and 2 billion pi? So that's how you represent every single value of theta in the universe, because the sine function and the cosine function repeat themselves forever. And that's the two answers. 2 pi n and 2 pi n, right? That means you go around the circle once and end up at the same place. round it twice, end up at the same place. Right. And that's a little idiosyncrasy for that one. Have you noticed that when you do things like calc, and this is going to be true no matter how many calc classes you take, things that you haven't used for a while pop in at the most unexpected places. I mean, yesterday, didn't we have to do the quadratic formula because nothing would factor? Right. Next time you do the quadratic formula might not be, you know, for 2 weeks. You might not do it again in this class, and then you go to Calc 2, and one day you'll turn up and you'll need to do it again. Or solve a trig equation, or use a unit circle, or factor something weird, or do properties with logs, or make square roots look nice. Do you see all the different little skills that you've picked up over the years? They get used in unexpected places. They just appear in a question and you think, oh, I'm going to have to deal with that situation. This, however, is not one of them. What method would you use to differentiate this function? And don't overthink it.
Product rule?
Yeah, just a product rule. In fact, in the big scheme of things, would you agree it's not the worst looking product rule you've ever done? So it's going to be f dash g plus f of g dashed. And now I'm about to do a deliberate mistake. Right, you got that guy, you got that guy, you got that guy, and you got that guy. What's missing?
The four and the E for the T.
When you differentiate e to the 4t, isn't it a little baby general, right? It's e to the 4t times the derivative of the inside function 4t. Now, in this case, I think pulling out the common factor wasn't really that painful. Would you agree? Wasn't that horrible? And so we now have our style points, right? We've factored the heck out of it, and it does look like the original. So critical numbers. When is the derivative 0 becomes solving when is this equal to 0. Well, we're looking if they exist for a value of t that makes that 0. And the other candidate is values of t that make that 0. Well, let's forget about this one for a minute. If you look at that, would you agree that that's going to be equal to 0 when t is -1/4? You do it in your head, right? -1/4. And can you use -1/4? Of course you can. In fact, isn't the domain of this function everybody? So if you can find it, you can use it. So there is, check, that one. And it's a little bit of a trick question, so I'm trying to figure a good way of phrasing this. What is the value of t, if there is one, that makes e to the 4t equals 0?
There is none.
There is none, which means that's the only critical number for the derivative being 0, right? There's just one. You cannot tell me, well, you might think, well, t equals 0 might work. Well, not really, because e to the 0 is 1. Well, can I pick a negative number? Sure, but you won't get 0 out of it. Can I pick a +1? Yep, but you won't get 0 out of it. Now, the second type of critical number is almost laughable, but I'm putting it in anyway. We are trying to find a value or values of t that make this fella undefined. Well, I can evaluate this at any value of t I like. Agree, so there isn't any. So there's only one critical number, that one. Are we good? Any questions? Okay, move on. So our next topic. Check them off my list. We're now going to actually find the absolute maximum and minimum value of a function, typically in a given interval. So here is the function. We're going to look for the absolute max and min. In other words, what's the biggest value this expression will equal to, and what's the smallest it will equal to if you only pick values of x from 0 to 4, right? So you can imagine it's a quadratic, starts down here, maybe finishes up there. Where do we go looking? Well, the first step, step 1, you differentiate. The function. Second step. Oh, almost forgot you do it. If you differentiate this function, you get nothing. You get 54 plus, oh, come on. Did I write that down right? I didn't. That's a minus. Okay, I can handle that. So you differentiate that, you get 54 minus 3x squared. So far, so good. Now, step 2. Find the critical numbers in the given interval. Well, I don't need to worry about this ever being undefined, but I do know that it is possible that the derivative is 0. So I'm going to solve that guy. Okay, solving equations, thinking cap is on. Right, as long as you do it to both sides, it's okay, roll. Start telling me something to do to both sides. Remember, our goal here is to solve for x.
Minus 54.
Would you agree the next line is divide by 3? Which I do not know what that is, so I'm going to find out. 54 divided by 3 is 18.
18.
Yes. Okay. Be careful here. What do you do next?
Take the square root, and then I think it becomes plus or minus.
That's the key. So you're going to get plus the square root of 18, and the other choice is negative the square root of 18. So there are actually 2 critical numbers. And if I want to, but actually it doesn't really matter so much here, I could rewrite it as 3 root 2 and negative 3 root 2. But since I'm interested in the value of the function, in other words, the final answer, I don't need to be too worried about making this look pretty. So that these 2 numbers are totally okay. Right. So far, so good. Right. So first step is differentiate. Second one is find all the critical numbers. Now I should check 3 times root 2. Let me check that. And if it isn't, I'll make it work. Can we change that to 6? Right. That guy is usable. Why am I kicking this critical number out? Because normally that would be a good usable number, but not this time. Why is this -3√2 being kicked out and not going to be looked at?
It's not within the range that we're given.
Right, so that one dies. So we have got critical numbers in that range, and there's only one of them. Oops, that's that. Where? What we now do in the third step evaluate the original function at the critical numbers and what are called the endpoints. So in this case, the critical number was square root of 18, and the endpoints are these guys, 0 and 6. They are called the endpoints. Right? So if the interval's from 10 to 20, the endpoints are x equals 10 and x equals 20, for instance. So the value of the function, which is this guy, root 18, the value of the function at 0, and the value of the function at 6. Right, at root 18, you get 6 plus 54 square root of 18s. Take away the square root of 18 cubed. And that's 6 plus 54 square root of 18s. Take away 18 square root of 18s. And what's that going to get me? 54 take away 18. That's going to leave me with 36. So I get 6, add 36 square root of 18s. Not very pretty, but that's the answer. This one's easy. I can do that in my head, but 0 plus a whole load of zeros, take away 0 cubed, and I get 0. And this one's a bit messier. I get 6 plus 54 times 6 cubed. I'm definitely doing that in the calculator. 6 add 54 times 6, take away 6 cubed, and the answer I get is 114. In the last step. The largest answer from step 3 is the absolute maximum, and the smallest is the absolute minimum. So I guess I should check that one, because that might be bigger than 114, right? So let me just check it out, see if it is. So I've got 6 plus 36 times the square root of 18, which is, would you agree, bigger than 111 or 114? So in my case, the absolute maximum is this guy. And the absolute minimum value of the function is quite clearly, at least in this interval, 0. And that's how you find absolute max and mins. And pretty much everyone that we'll be doing will look like these 4 steps. Does it seem that there's a logic to what we're doing and why we're doing it in this order, right? And it's all about critical numbers and the value of the function at the endpoints. So here's our next guy. Version equation 16. So I'll find its derivative. So that's a chain rule, 3 lots of 10 t squared minus 9 squared times the derivative of the inside function, which is 2t, and then just make it look pretty, 6t t squared minus 9 squared. So that's essentially step 1. Would you agree this function doesn't have any derivatives that are undefined, right? There's anything can get used, but it does have places where the derivative is 0. So in this case, 6t t squared minus 9 equals 0. Okay, this guy here gives me a t equals 0, and this guy here gives me a t equals 3. Does he give me anything else? Is there any other values of t that make t squared minus 9 squared 0? I've give you one of them, which is 3, but what's the other one?
-3.
Okay, now here are the 3 critical numbers. I don't need to look for undefined. It's clearly there aren't any to look for anyway. Can 0 work? Yes, it's in the interval. Is 3 okay? Yep, it's in the interval, at least this time. Is -3 okay? Yes, it actually happens to be at the endpoint, but it is usable, right? So, right, we've found these guys. Find the value at 0, value original function, value of the function at 3, and the value of the function -3 then. If you plug in 0 to the original, you get 0 squared minus 9 cubed, which is 9 cubed, which is massive. And 9 cubed is 729. If you put in 3, you actually get the exact same answer. And if you, no, you don't, my apologies, you get 0 cubed, which is 0. And then if you put in -3 squared, take away 9 cubed, you also get 0 cubed. Well, we don't have too many choices there. The absolute minimum value is 0, happens to occur twice. And the absolute maximum value of this function is 729. So if you put that function into Desmos, whatever, and you said only use values of t from -3 to 5, the highest value, right, the maximum it would ever get to would be a height of 729, and the smallest it would get to is 0. So would you agree in this range, that's the range of values, right? Absolute minimum doesn't get any lower than that, doesn't get any bigger than that. Any questions? We good? Here's a weird fraction one. What am I going to do about 9 over x? I want to differentiate it, but if I leave it as 9 over x, I'm going to be in trouble. I have to rewrite it. How will I rewrite 9 over x?
X to the -1.
Correct. Now, differentiation is not too bad. That guy is 1. Multiply by the power, reduce it by 1, and then do Some style points, nothing too bad. There's step one done. Okay. Let's look for critical numbers now. Let's solve when is the derivative 0. Okay, you get what you get. In this case, we got this guy. As long as you do it to both sides, it's okay rule. A couple of different ways to approach this question, actually, and I'm looking at it. Anybody
Minus
suggest? Say again?
-1 off both sides first.
Yeah, I could. Nothing wrong with that. We're going to do next.
Times by x squared.
Okay, well, essentially cross multiply. We're going to do next.
Times by -1 to get rid of the negative, then take the square root.
And so got a +3, we've got a -3. So far, so good. Right. Are any of these two guys not usable? Look at the interval.
A -3.
So forget him. Now I'm going to talk the next one through around writing. This is a derivative, right? We're interested in critical numbers, so we should also be looking for where it's undefined. Would you agree that this function is undefined at x equals 0? But x equals 0 isn't in my interval, so I'm not going to use it. So if you're wondering what happened to that, I just did it in my head, but never necessarily wrote anything down. Which means we now have the value of the function at the end point, the value of the function at 3, and the value of the function at 12. And whichever one of these is the biggest, that's the absolute max, and whatever is the smallest is the absolute min. And you got to remember we're doing it with the original function. So this is going to be 0.2 plus 9 over 0.2, which is definitely a calculator question. 0.2 add 9 divided by 0.2, and the answer I get is 45.2. The value of the function at 3 is a little bit prettier because it's 9 over 3, and that's 3 and 3 get me 6. And if you do 12, it's 12 plus 9 over 12, which is 12 3/4, which is 12.75. So the absolute maximum value of this function is 45.2. And the absolute minimum is that guy. We're done. I like these questions. Don't they have a nice flow to them? You kind of do the same thing. A little bit of algebra changes, depends on what you got, but that came out quite nice. Okay. 19. Pick this one because it's a fraction. So I know I'm going to be doing quotient rule. It's going to be f dash g, take away f of g dashed, all over g squared. And I don't know why I'm on that color. I like this color better. Differentiate the top, you get e to the x, leave the bottom alone. Take away, leave the top alone and differentiate the bottom. And the whole thing is the bottom guy squared. I could distribute this and then pull out the e to the x, or I could pull out the e to the x and leave what's behind it, don't matter. But after a little bit of tweaking, you're going to get that. I've probably missed a line or two there, but are you comfortable with what I just did? Is there anything you could do style points to this quadratic.
You could factor it.
It is, it's an x minus 1 squared. It's an x minus 1 times an x minus 1. You can factor it. Now that I factored that, it's finished, right? Its style points are make it look like the original, which it does, and factor the heck out of it, which I've just finished. Now, if you didn't notice that that was equal to that, the next step's going to be a bit harder than it would have been. Let's find the critical numbers now. So we're going to see when the derivative is 0, which happens only when the top, the numerator, is 0. And this guy is never going to be 0, agreed? E to the x just can't be 0. You try, you won't get anything. On this, isn't there one possibility? X equals 1. Right? That would be 0 when x is 1. And it is usable because it's in this range. Now, if you'd left it as x squared minus 2x plus 1, wouldn't you say x squared minus 2x plus 1 equals 0? And then you would have solved it. And you would have eventually found out that it was 1, but it would have probably taken you more work to do that. Now, there is a second possible critical number, and that you really don't worry much about when it's a fraction, and that is undefined. Now, this looks like it might have 1, but you're only going to be undefined when the bottom is 0. There is no value of x that will make this 0. So here's the argument. Isn't 1 plus x squared going to be at least 1? Because x squared is positive. And if that's at least 1, a number that's 1 or bigger squared can never be 0. So we only have one critical number, and it is x equals 1. And so we now find the value of the function at the endpoint 0, the value of the function at the critical number 1, and the value of the function at the endpoint 4. And if you plug 0 in here, you get e to the 0 over 1 plus 0 squared, which is 1. And if you plug 1 in, you get e to the 1, which is just e, over 1 plus 1 squared. So you get essentially a half e. And if you plug in 4, you get e to the 4 over 1 plus 4 squared, which is 1/17 e to the 4. Now, whatever one of them is the biggest is my absolute max, and whatever one of these is the smallest is my absolute min. But I'm not really sure if 1/17 e to the 4 is really big, and is it, if it is big, is it bigger than a half e? So I'm going to go and do the calculator and find out what they are as decimals. So 1/2 e, well, just call it 0.5. There's the e button, is about 1.36. And this fella here, well, it's e to the power of 4 divided by 17. And this ends up being 3.21. Ah, now I know. Isn't this guy the biggest of the 3? And isn't this the smaller of the 3? Right. So 1 is smaller than these two. So there's my absolute minimum. And this horrible expression is about 3 and a bit, and it's better than any of the other two. So this is my absolute max.
Is the value that's not the biggest or the smallest, is it nothing, or is it like
Yeah, it's just nothing.
Nothing.
Non-interesting, doesn't even have a name. It's like the middle child. Nobody pays much attention to them. Right? Hopefully nobody here is a middle child. Okay, we good? I think we've got time for one last one. Perfect, because it is the last one. Of course, keep the best till last. You might be getting the condensed version here because simply just time. If you differentiate this fella, you get -2 sine t. Oh, shooting space. I almost forgot. I'm going to rewrite the sine of 2t as this guy. So it's a little trig identity. It's called the double angle formula. Now I will differentiate. If you differentiate 2 cosine t, you get -2 sine t. This guy's going to be a product rule. So it's -2 sine t. If you differentiate this guy, you get 2 cosine t times cosine t plus 2 sine t. And if you differentiate this, you get negative sine t. And it looks like I've got -2 sine t plus 2 cos squared t minus 2 sine squared t. And I wish that had been a plus, but it isn't, and I know it isn't, so I'm not going to be too concerned that, you know, it didn't end up being nice. But it does make our life a little bit difficult, because I have to solve when is this fella equal to 0. And my trig class haven't done this guy yet. I think they'll be doing it the beginning of tomorrow. But I do know that you have done these. These are trig equations that involve sines and cosines. And what you need to do is you need to change them all into, in this case, sines. So that's good. And this is good. 2 cos squared can be written as 2 1 minus sine squared. That is another trig identity. So I now have -2 sine t plus 2, take away 2 sine squared t, take away another 2 sine squared t equals 0. And we have -4 sine squared t, -2 sine t plus 2 equals 0. So if you get an equation like this, turn everybody into sines or everybody into cosines. And I wish I could say, oh, well, we're almost done, but we're not almost done. We've still a fair amount of work to do. I'm going to multiply both sides by -1. Can anybody see any common factor here?
2.
Yep, it's not a lot, but every little bit helps. Now, the trickiest part, which people, if you remember doing trig, probably blocked out their mind, is that this can be factored. The 2 sine squared t give me 2 sine t and sine t. The number 1 gives me a 1 and a 1. Since this number has to be -1, one of these two is +1 and the other one is -1. Any takers for which one goes where? Because when you FOIL it out, you should get this thing back. Think of it as 2x squared plus x minus 1. Right, it's essentially, that's what it is. Who gets the plus? Who gets the minus? You know you have a 50-50
The one on
chance
the
of guess.
left, right?
Say again?
The one on the left gets a minus, right?
This one here gets the minus, and this one here gets a plus. Correct. So what we can now do is, what makes that 0? What makes that 0? Right, this one, 2 sine t will have to be 1. That makes sine t have to be a half. This one, the sine of t has to be -1. Right, unit circle. We're only interested in angles in 0 to a half pi, which means the answers must come from here. And when is the y value a half? At pi upon 6. I can use that, so that's a critical number. When is the answer -1? Well, technically speaking, the answer is -1 down here, but we can't use it because it isn't in here. So that one's got nothing. I don't have the time, but you find the value of the function. That's this guy. At the end point 0. You find the value of the function at pi upon 6. And you find the function at that. And one of these three is the biggest, absolute max. One of these three is the smallest, absolute minimum. Right, thanks for hanging on. I overshot my time a little bit. Sorry about that, but I kind of wanted to get this one done because it is the last question from that section. So last name and bye-bye.